6:30. Let's start right on time. Welcome everybody. My name is Kambiz, just in case you don't know me, and I'm with Home Depot. And thank you very much for coming. And before we start, there's a big thank you to Crane for hosting such a wonderful event and venue. Yeah. And Paul Reese is a friend and partner. He helped us a lot with this project at Home Depot. So.
Yes, thanks. We love hosting these kind of events. This is our Executive Briefing Center here in Atlanta. If you ever want to hear about leading edge mobility or wireline data networking or even our strategies for how we enable mobile applications, please talk to your Sprint representative or email me and I'll get you in touch with the right people. This venue is certainly open to our technology partners, and we appreciate our relationship with Home Depot and with Tech Exec. So thank you.
Thank you. So, just take an announcement and the time. The next event, we just booked a room at the Home Depot corporate office across the street, across the highway, and on January 16th. And already put a link up, and hopefully see everybody there. Just one thing, please, when you RSVP, make sure you put your real name because we do some sort of check, background check, and you don't want any kind of issues when you come there. Just again, sometimes it's a hassle, but they have very nice accessibility there. And also the other sponsor that we have is Oral Company and Tech Exec and Plum, and Knox is not here, but again, thanks for everybody to providing support for this venue. Okay, so the agenda, we already halfway through, and our guest speaker is Mr. Don Turner, and he was one of the greatest speakers of our organization, and talking about something that usually people don't think much about it or don't talk about it, and that's artificial intelligence and big data. And I wanted to try to introduce him because the introduction is so long.
I can't hold it down.
Yeah, there you go. So, without no further ado, Mr. Turner. Okay. Thank you. Let me change the.
How you doing? Yes.
I have a speaker if you like. You want a speaker?
I've got one. Thank you. I think I can move around all here instead.
Yeah.
Here we go. Okay. Well, I was asking you a quick few minutes of my background. I do have somewhat of an eclectic background. I'll start off with a small cabin deep in the woods in northern Michigan, and we'll go on from there, okay? And usually I'm like 2 hours. Seriously, my background is about a third. Right now, I'm president and CEO of VELOXITI, the artificial intelligence software, and we're going to talk about AI and big data. Obviously, it's the topic of tonight. But as I said, my background is about a third. So, part of my background is international strategy work. I've worked with McKinsey, Booz Allen, KPMG, Ernst & Young, and set up several strategy practices. We built the Bogey strategy methodology that's been used by over 100 corporations. We basically spent about a third of my career traveling all over the world doing strategy for technology-intensive companies. About a third of my background is corporate. So I've been group president and officer running up to $200 million in a public company. And I've also been chief strategy officer during a $1 billion IPO that I architected and helped do the IPO. And then about a third of my background is a CEO in turnaround situations and small tech companies coming in. I was brought into this company in May of 2011. For the last 10 years, I've been a CEO of about 8 companies, and in between CEO gigs, I go help other companies do strategy. So I'm normally only in companies 9 to 12 months. I've been in this company for like 2.5 years, and I told the board I'm not expecting a Rolex, but maybe a Timex, a Swatch, something. So we'll see if I get that for Christmas. But I have had really, it's been a blessing with my careers. As I tell people, I don't mean it's a self-serving remark, but I've been in more companies and seen more business situations than most people see in 20 lifetimes. It's just the nature of my career. And I've also had a chance to work on the leading edge of a lot of different technology. I started off in the automotive industry, process engineer for General Motors, and then after I got my MBA, went to work for Booz Allen. I was one of the first members of their technology strategy practice based out of Paris. And so, again, eclectic background, but I've had a chance to be, I was one of the pioneers in high-end computer simulation modeling. I've worked with super minis, mini supers, so I've worked with a broad range of stuff. As I tell people, there's nothing in the world that I don't know that I know somebody else who knows it better than me, except for maybe Star Trek trivia. Other than that, I just need to know who I can go to for expertise. But as we go through tonight, I want it to be informal. I've got a lot of information. I'll probably skip over some stuff. I don't know if you're going to make the slides available.
You let us do that.
Yeah, you're more than happy to. But I'll tell you a little bit about Velocity, and then we'll get into the subject. So Velocity is a company that was started in 1989 by Dr. Norm Geddes. And for about 20 years, it was primarily a research house for the Department of Defense and the intelligence communities. Mostly writing white papers, did do some proof of concepts, but in May of 2011, the board approached me about coming in, revitalizing the company, and taking it into the commercial space. One of the first things I did is I looked at the software. I came to the conclusion that we had to completely rewrite the entire artificial intelligence space, because I asked one of my best AI scientists, and by the way, I got very smart people in my office. If you want your IQ to go up 10 points, just come in and breathe the air. I got a young lady, got a college degree at 16 or 17, a PhD at 20. I got smart people. Now, our company parties are not the wildest, but I've got some pretty smart people. But I asked one of my best AI scientists, I said, how long does it take to get somebody up to speed using our software? And ours is good or bad as anybody else in the industry. He said about 9 months. I said, oh my goodness, I can't scale that. So we started in the fall of 2011 and completely rewrote the entire cognitive engine and the development environment with the idea that we wanted to take AI to the masses. That is our mission statement. AI has been around since the 1950s. John McCarthy coined the term at Dartmouth, artificial intelligence, in 1956, the year I was born. So it's been around a long time. It's had starts and stops, and a little bit later on, if we have time, I'll go through a little bit of history of AI. But one of the things that we did, we completely wrote the software into Java, and we now have the ability to take a reasonably proficient Java programmer, and after 3 days of training, they can be building intelligent agents, which is a form of artificial intelligence. We'll talk about different types of AI and stuff like that. So that's a little bit about the company. Again, we still do a lot of work in the DoD, intelligence community, but we're now moving to the commercial space, and we're starting to do some work there, and I'll talk a little bit about that. Okay, so as we go through, any questions, feel free to ask. So, the role of AI in big data. Just so you know where we're starting from, we put this in context, is my philosophy is big data without artificial intelligence is computational stupidity. You can't do big data unless you got AI. Predictive analytics and statistics and heuristics only take you so far. Any problems with that? So at least you understand where I'm coming from, right? Real quickly, we'll talk about, big data this year is getting bigger, though the potential is comprised by a lot of challenges with big data. Everybody knows if you're in the space of big data, you know the problems that we're experiencing. Big data is an opportunity, but it's also a problem right now. Artificial intelligence is right now concurrently becoming ready for prime time, so we can start using AI techniques to help us deal with big data. I think they're symbiotic, and they will continue to be so. And artificial intelligence can and will eventually replace humans in specific tasks, but today, a lot of our focus is not replacing humans, but augmenting humans, helping one human do the work of 5 or 10. And we'll talk about that in a little bit. So, we're going to talk about why is this important. Why should you care about artificial intelligence in the topic of big data? I'll define big data very briefly. I'm in a room probably with a bunch of big data experts, so you know all the stats. So we'll spend some time on artificial intelligence. How many people have been exposed to artificial intelligence? Okay, a few. Okay, after today, you're going to be the hit at this weekend's cocktail party. We'll give you some great buzzwords. We'll talk about the symbiotic relationship between big data and AI, walk through some examples, and then I'll tell you what I view as the future, and then I'll try to leave enough time to do questions and things like that. Okay, good stuff? Big data is here. The big is getting bigger. We're spending a lot of dollars, resources, and time being dedicated. I remember in of course I keep dating myself, in 1984, I was looking at a big advertisement in the Wall Street Journal, and I'll never forget it. It was a big cartoon, and it was this IT manager standing in front of this humongous desk, and the CEO is behind him. And he's talking to his IT manager. He says, Simpson, go get us a relational database. I don't know what it is, but everybody else is getting one. And that's kind of the way big data is right now. People are spending a lot of money in big data, and they're not getting value from it. Some are. I would suggest that most of them are not. It's creating problems, overwhelming resources in technology, people, and processes. And potentially, people are spending so much time on big data that they're not spending time on other core functions of the business that would generate a quicker return. I mean, big data is real, it's powerful, it's got great potential, and it will benefit a lot of companies. But you've got to know how to get into it, and right now we're struggling. We're on the cusp where big data is taken off, and we're not quite sure how we're going to do it, how we're handling it. Gartner says that half of all big data spending next year will be wasted. That companies will spend tens, if not hundreds of millions of dollars on big data, and it's wasted. They also said, by the way, because we're creating so much data, we don't have enough people to look at it, because the predictive analytics and computer programs can only go so far. At some point in time, a human has to make a decision if it's a complex problem. And computers and humans are uniquely configured to make decisions. Computers not so much. Computers are phenomenal at number crunching, phenomenal at identifying numbers and computing the numbers. But you know, the good Lord gave us a pretty good computer between our ears, and there's still value to that. Enter artificial intelligence. So not a lot of people paid attention in 1997 in the second rematch when Big Blue beat Kasparov. You know, I'm a chess player, so I paid attention. That was a big deal to me. But when Watson in 2011 beat these two Jeopardy champions, and they said it was artificial intelligence, people paid attention. Because up to then, most people, when you mention artificial intelligence to them, they either think about Lost in Space, Terminator, or Big Brother. They really don't understand artificial intelligence. But by the way, AI is all around you. You just don't see it right now. Largest AI company in the world right now, anybody know who it is? Google. Google has Norbig and Kurzweil both working for them. Norbig is one of the co-authors of the definitive book on artificial intelligence that everybody cuts their teeth on in the world of AI. And we'll talk a little bit about what Google's doing in a little bit. So today, my proposition for you is that big data, we need help with it. And artificial intelligence is finally, after some starts and stops in 50, 60 years of fooling around with it, is finally getting to the point where it can help us in prime time. And that's really the focus of my discussion tonight. So what is big data? Well, again, a bunch of big people here that deal with big data. I'm not going to try to define it for you. The common term is big. It deals with a lot of structured, unstructured data. 90+% of the data going across the internet right now is unstructured. It's often defined along three dimensions: volume, velocity, and variety. And people are adding 3 or 4 more dimensions, including vocabulary, venue, and the veracity of it. But remember that big data is relative in context to the market. One person's big data may be another person's Excel spreadsheet. It's all relative. So when you take a look at B2C type, business consumer type applications, they're talking about billions of transactions. Businesses maybe not so much in a B2B world. So you've got to take your big data and put a context of the volume and the velocity and the speed of that particular marketplace when you look at defining what is big data. But again, it's the buzzword du jour and everybody's talking about it. I would quantify big data, but in the last 60 seconds it changed since we started talking. We've seen these, in the last 60 seconds, 350,000 tweets, 695,000 Facebook status updates, 11 million instant messages, 3.5 million Google searches, $118,000 spent on Amazon in 60 seconds. So I kind of think it's funny when people say, well, here, I'm going to pull together this big data stack. And it's really just saying, well, we know your numbers are wrong. What do you mean they're wrong? I just got them today. You got them 60 seconds ago. They're wrong. Things are changing. 90% of the world's data was created in the last 2 years. Bottom line, there's a lot of big data. It's growing exponentially. It's not going to slow down, and it's not going to stop. The question is, how do we get on this horse that's already left the barn? Why is big data getting so much bigger, so much faster? This is my view of it. Computers are definitely a reason. Computers are getting faster, cheaper, they're more ubiquitous. Moore's law is alive and well. If one computer's good, two must be better, right? Computers are cheap. Everybody's got a computer with their smartphone. It's amazing. You go back, I think the smartphone, they say, the typical phone that we carry right now has got, I forgot the number, 7 times the power of ENIAC, that room-sized computer back in the 50s. But something that is symbiotic to the computers is the sensors, the input sources. There's more ways to collect data today, more input sources. Virtually with every breath we take, we are being measured, monitored, and managed. Your phone, the phone company knows where you're at. I have to work a lot with the DoD, so I know things that a lot of people don't, so we won't discuss those, but I have no problem with the government knowing what they know. But there's so much data being collected about you, and you're being exposed to so much data. I remember years ago they did a study in New York City and said the average, and how many people have ever done the commute, lived in the New York metropolitan area and done the commute into the city and all that? A few? You have my sympathy. I did it for 2 years, no more. I lived in about 26 miles from the World Trade Center as a crow flies, and it would take me about an hour and 20 minutes to get to work. Because we didn't have an express train, we picked the local train, and then I picked up subways and all that. But they said the average New York commuter in about 1992, from the time you woke up in the morning and you listened maybe to the radio while you were in the bathroom, or reading the newspaper, or walking down the street and having a bus go by you were exposed to over 20,000 different commercial messages in one day, as an average New York commuter. So and now you put that on internet speed, there's even more messages that are trying to get to you, trying to influence you. That's all part of big data. Computers and sensors are symbiotic. We're talking about recording everything right now. Right now in healthcare, they're talking about being able to put a micro-electrical-mechanical system as a heart monitor that's powered by your own body energy and allows people who have had a cardiac procedure to leave the hospital like 2/3 quicker than they would normally. They can go home and monitor it. And also, they may get a phone call and say, "Hey, we picked up something on your heart or some palpitations. We'd like you to come in immediately." But it allows you to get home. And the quicker they've proven, the quicker you get people out of the hospital, the healthier they are, the better the recovery. Because I know this is new news for you, but there's sick people in hospitals, and if you're around other sick people, you got a chance to get sick. But computers and sensors are driving this big data. They're everywhere. Now, is this big data or big basement? Don't know. It's kind of like when the dog chases the car. It doesn't know what to do with it if it actually catches it. We start collecting all this data, we don't know what to do with it. We know that the majority of the data being collected today is not being analyzed, yet we're spending billions of dollars to collect it. If some data is good, more must be better. If it's so easy to collect, so hard to get rid of. So that's kind of my quick view on big data. Again, it's big, it's getting bigger faster, and it's not going to stop. The horses, as they say, already outside the barn, we're trying to play catch up with it. Because nobody talks about big information. Nobody talks about big decision making. You don't make money by collecting big data. You make money by big decisions. And we've got to get from big data, big information, to big decisions. So I'm going to spend a little time on artificial intelligence. Again, if you have any questions here, feel free to ask. I'd really like to spend a day talking about AI and all the different techniques. I'm fascinated. As I mentioned to you before, one of the neat things about my career is I've had a chance to work on the leading edge of a bunch of different technologies. And I am passionate about AI because I believe it's the future. Another part of my background is doing a lot of strategy work for corporations and predicting what's going to happen with technology. I could throw out all these fancy McKinsey and Booz Allen gobbledygook strategy words, but the essence of strategy is to identify a trend that you're willing to invest in. That's all strategy is. It's being able to look over the horizon, see something that you think is going to become more and more important, and invest money in it. In fact, when we talk about AI and big data, one of the things we need to be thinking about big data is, I'll go off for a second and I'll get on my 2-minute soapbox and I'll give you my definition of high-tech marketing versus traditional marketing. Okay? Now I'm going to have to kind of explain some of this for you because I know some of you are young enough you're not going to know what I'm talking about. We're going to give it a try. Okay? So traditional marketing, what do? You go out and you interview enough customers, you take a sample size, you find a need. If it looks like there's a business case there, you come back, you build a product, and you sell it to them. That's traditional marketing, right? High-tech marketing, the customer, the company, the user, the consumer, doesn't understand the technology well enough to even know what to ask for. So I'm going to go back in the late 70s, and people are walking around with these big boom boxes. I'm going to explain to you. That's like really big radio people used to carry before they had Walkman. okay? And if you ask the consumer what they want, they'd say, you know, it's kind of heavy. I'd like a rubber pad on the bottom of it. It only takes 6V batteries. I'd like to throw 12V batteries so it plays all day at the beach. That's what they would say. They didn't know any better. It's kind of like in traditional marketing, if there's 92 million households in America, you find out that 11 million households have 5 people in the house, and of those 11 million households with 5 people in the house, there's 7 million of those households that all would like toast in the morning. The toasters only come with 4 slots. So I put together a business case and say, you know, I think I can sell 3 or 4 million 5-slot toasters if we do this themselves. Again, that's traditional marketing. So we go back to the boombox. They didn't know what to ask for. Sony at the time was the world's best in electronic miniaturization. That was a core competency. Okay? And what they did is they didn't ask the consumer what they wanted. They identified a macro trend. And they said, you know, people are listening to music more and more in a mobile fashion. We think that's going to continue. And we think it's worth investing in. So what they said is, what can we do with the voodoo we do to change what they do? Nobody, if you ask them, and you ask consumers back then walking with big boom boxes, nobody said, well, I'd like something about this size that I can throw in my belt with some headphones. Because they didn't know it was possible. So that's the challenge with anybody dealing in the world of big data, particularly on the revenue side, in sales and marketing, is you got to use high-tech marketing. You got to go in there and understand how can I fundamentally change my customer, my business, or whatever with the voodoo we do relative to big data. So, as I already mentioned, computers are getting bigger, faster, cheaper, but computers in the future just can't do more massive number crunching. What they really need to be is human assistants that help in the process and the thinking better decisions. Because if I don't have this, and all I've got is this, there isn't enough carbon-based life forms to analyze the data. So trying to define AI is kind of like, I guess, defining love. Everybody's got their own opinion. You're not quite sure what it is, but I guess you see it. You know, when you see it, you kind of say, okay, I guess that's love. Well, the power of AI is a very diverse field. It covers multiple techniques with different capabilities and limitations. We're going to talk about neural networks, associative memory, case-based reasoning, expert systems, intelligent agents. Those are all different types of AI techniques. And also, the term AI conjures up other thoughts. People really don't understand what artificial intelligence is. Another problem is if you ask 10 AI professionals to define AI, you'll get 10 different answers. Some of them will take an emulation, a physiological approach on how the human brain works. Some will focus on human senses. Others will focus on human behavior. And guess what? They're all right. AI is an amalgamation of a bunch of other scientific disciplines. Economics, psychology, bioscience, control theory. All of those are disciplines that have contributed for the last 50, 60 years to the field of artificial intelligence. And the last thing that makes it even more difficult to define AI is today's AI is tomorrow's off-the-shelf product. Now that they're tearing down the toll booths on Georgia 400, which I applaud, by the way, but as you went through there, they had a camera that took a high-speed photo of your license plate. They would process it using a neural network-based algorithm, an AI approach, that used to be considered AI, but now it's just considered an off-the-shelf product. When you get your little button and you talk to Siri, that used to be AI voice recognition. Voice recognition is not considered AI anymore. So that's part of the challenge we have in the field of artificial intelligence, is that today's AI is tomorrow's off-the-shelf product. So it's a constantly moving target. That make sense? What is it? So in order to define artificial intelligence, we need to define intelligence. Of course, the old joke among the field is if there's artificial intelligence, there has to be natural stupidity, and we've all seen that. But intelligence is generally viewed as the ability to respond to situations flexibly, to make sense of ambiguous and contradictory information, to recognize the relative importance, to put things in perspective and different priorities. Intelligence is, I have a glass of water and I'm thirsty, but there's a freight train bearing down on me. Intelligence says, you know, that's probably a little bit more important for me to deal with than my glass of water in the fact that I'm thirsty. Okay? And it makes rational decisions based on observations. Artificial intelligence is a field of computer science that builds intelligent agencies to satisfy those criteria. Generally two types. We call them special purpose AI, focuses on augmenting the human intelligence. The AI you find in your phone, the AI you find when you call customer service, those are all special purpose AI approaches that are very task specific and are focused at augmenting the human. You'll typically, when you call it now with customer service, I don't know how Sprint is. I haven't called Sprint's customer service in a while, but normally you're going to interact with the computer for about the first 2, 3, 4 buttons, and even probably the first 3 dialogues. And then eventually you'll get a human, maybe. Good examples are, you know, voice recognition, translation, vehicle control. And that's really what industry is adopting, is special purpose approaches. Now the field of general AI has actually looked at actually replacing humans, and there's a lot of research in this area, but it's a lot more difficult. Humans are an amazing creature if you take a look at the brain, and you take a look at how it works. Now, AI techniques differ on how they think and how they act. Now, I'm going to not go through all the detail here, but one way that we in the field of artificial intelligence look at AI is in 4 quadrants. My little button actually works here. Not very well. So we look at the performance measurement. Is this versus humans or versus an ideal rationality? We take a look at the focus. Are we focused at emulating the thought process or behavior? For example, if you're focused really on looking at the thought process and the processes on how a bird flies, when you make an airplane, you make an airplane with the wings flat. Well, that's not what we do today. What we do is we have planes with fixed wings, and we learn what creates the lift on a bird with thrust. And instead of trying to get all the complexity of moving that phenomenal airfoil form that the bird can do naturally, we have fixed wings and we simply throw a bunch of power behind it so we get the lift. Those are the folks that are over this area. It doesn't work like a human, but it acts rationally. So it's all different fields. And if you take a look at these between expert systems, neural networks, probably at least a lot of people have heard of neural networks. I mean, all AI people cut their teeth on neural networks. Associative memory is a flavor of that. We'll talk about it. Intelligent agents, I have to think, is the most exciting. We'll talk a little about intelligent agents, rational prime decision making, and then there's things like machine learning and fuzzy logic. You know, example of fuzzy logic is a mother is checking her child's temperature, puts her hand on the forehead. She doesn't say, that's 101.43. She says, you're warm. You need to lay down. Humans are amazing at fuzzy logic. And now we're applying fuzzy logic to a bunch of different applications. And fuzzy logic is in your car, it's in your TV, it's everywhere. And one of the things that you've seen as we go through, and I mentioned Google is the largest AI company, it's transparency. People don't realize that there's AI there. What we're hoping, and what we're betting our company on, is that the world is ready for AI to bring the masses. Right now, all this AI is custom grown. People write this software from scratch. Our focus has been to create a development environment where any company can build their own intelligent agent and their own AI technology. So that's what we're trying to do, is trying to move this from homegrown, one-off type AI applications to a much broader industry. We'll see if we're right or wrong. I mentioned that AI is driven by all these different disciplines. All these different disciplines have contributed to the world of AI since the 1950s. In turn, particularly in the last 5 years, AI now is starting to contribute back to these disciplines. What we're learning in AI is helping the area of psychology. It's helping the area of control theory and cybernetics. So there's been this great quid pro quo with artificial intelligence and all these other disciplines. That's a quick overview on AI. Again, look at an environment, understand your situation, be able to prioritize, be able to make decisions, even in terms of ambiguous and uncertain information. That's what intelligence is. And all artificial intelligence is using the computer to try to emulate that. That make sense? Any questions with that? Why does big data require artificial intelligence? Well, you know, the big problem with big data is there's not enough carbon-based life forms, as I alluded to a little bit ago. The buzzword du jour is predictive analytics. IBM actually built a whole division around that. It can deep mine, it can identify trends, it can set the stage for decision. However, at some point, for a lot of these things, you still need a human to take a look at it and make a decision. The problem is big data is self-propagating faster than human species. We keep getting more data, translated into more information, but not enough humans to think about it. Ergo, we're falling behind on the decision-making capability that is there from the data that we're collecting. There are two divergent paths. And that has to change. Or why do we keep collecting all this big data? But half, as we said, over half of it's not being looked at right now anyway. Now, the hope is that at some point in the future, somebody will go back to that and say that particular transaction on June 14, 2011 has value. It may or may not. I doubt it. Because by the way, particularly, you know, the future, one of the focuses of AI is, as the term goes, is predictive analytics. Predict. The accuracy of prediction is far greater, closer to when the data was collected and it was created. Okay? Trying to predict something on data that is a day old, a month old, a year old, or 10 years old provides different levels of accuracy. Big data, proposed to requires AI. I think the reverse is true. AI has been around for a while. It's been a multi-headed solution looking for a problem to solve, and big data is primed for it. Because big data, what does it do? It creates a lot of data, a lot of uncertainty, and a lot of questions. Well, guess what? AI requires a lot of data, particularly for self-learning, machine learning systems. It thrives on uncertainty. It can see patterns that humans can't see. And it's singularly focused at answering questions and making decisions. In other words, big data without intelligence is, well, stupid. My proposal is AI without data is not very intelligent. The two really need each other. How can AI help big data? There's many ways. The two that are compelling, and we can talk all about various types of visual recognition and different technologies that are out there. We'll throw a list up at the end just so you understand all the buzzwords and all that. But two of them that are really compelling is pattern recognition and high-speed decision making. So I want to take about 10 minutes to talk about that. Okay? Pattern recognition is textual, data, audio, visual, and there's two common AI approaches: neural networks and associative memory. In turn, AI-based decision making must emulate how humans process information and think about it, and that involves intelligent agents and intelligent associates. Let's talk a little bit about neural networks. Neural networks are based on the brain metaphor: ones and zeros, neurons and synapses. This day, there's so much about the brain we don't understand. It is an amazing, amazing device. It's a large number of simple neuron-like processing elements. I mean, the brain is consistent of this massive array of billions of just ones and zeros. But yet, we can think, we can visualize, we can process, we can feel, we have behaviors. Just with that world of ones and zeros. We have wave connections between those neurons. It's parallel distributed control with an emphasis on learning. The brain has an amazing ability to learn stuff. Consider optical character recognition. So as you look at all these layers, they're just ones and zeros. What it does, it looks for a horizontal bar. Another one may look for a diagonal. Another one may look for a vertical bar. After a while, the combination of all these units determines that it's a 7. It now knows that that combination of ones and zeros represents a 7. It can remember that, and there next time it goes and it sees a 7, even close related to that, it knows it's a 7. Okay? Neural networks are by definition machine learning approaches. Not all artificial intelligence is self-learning. Particularly when we work with the U.S. military, we have the ability to have the machine learn, but it has to go through a human, because the military is very concerned that the machine does not learn bad behavior, bad decisions. So we always make sure a human vet that. That's neural networks. That's kind of how that works. You see it pattern, you see it in visual recognition, audio recognition. You know, how many people do Pandora? How many people are on Spotify, by the way? Man, you gotta get with that. I'm a walking advertisement for Spotify. I know this is embarrassing to say, how much money do you spend on iTunes? I have over 15,000 songs on iTunes. I know that. I wish I had that like that. I have not bought a single song on iTunes in 2.5 years. Spotify is amazing. $10, you know, I got access to 15 million songs. I can download them, I can do anything. And its intelligence in looking at the type of music that I like, it's really outstanding how it can bring me, and that's how I'm discovering all these new artists. Edward Sharpe and Zero Magnetics, regular group. I know you've heard their songs, you just don't realize it. Let's talk about associative memory. So both neural networks and associative memory deal with connections, associations. Neural networks emulate the brain's neuron synapse 1 and 0 paradigm. Associative memory, one way to think of them, how many had a stats course and know what a correlation matrix is? You. Okay. A correlation matrix is basically a matrix, and it coordinates the relationship of variables here to variables here. Associative memory is correlation coefficient matrices on steroids. It remembers every pairwise association. What happens is it creates a occurrence matrix for each outcome, the cross-reference. There's this thing called the attribute value pair, and what happens, it starts to identify that when these three things occur, this thing is normally associated with it, and it starts learning. And again, associative memory is a lot like neural networks. The more stuff you feed it, the smarter it gets, which is why these types of techniques are particularly well suited to big data, because they love big data. They just chew it up. But now my favorite, intelligent agents. So an intelligent agent, as we view, is kind of the umbrella of all these other AI techniques. We view intelligent agents as that AI approach that actually can manage other AI approaches. And an intelligent agent is basically a computer representation of how a human thinks. It can perceive its environment, it can interpret the situation, it can make decisions to accomplish a goal. They continually perform several functions. They perceive the dynamic conditions in the environment. They evaluate those conditions in the light of a belief system. And I'm going to talk about what a belief system is. We all have a bunch of different beliefs in our own belief system. And when a belief system reasons that action must be taken, we initiate it in pursuit of a goal. I believe I'd like to stay at a comfortable temperature. If I'm outside and I have a coat on, at some point in time, my belief system will say, hey, wait a minute, I've hit a threshold where now I'm cold, I need to go get a coat on. That's how a human would think, and that's how the computer should think if it's representing how a human thinks. Agents differ from normal software programs in really 4 ways. One, it's typically smaller. It sits on top of a program. It consists of a human or another computer program. Okay? It has a specific purpose, while programs typically multi-purpose. Agents' lifespans not depend on user launching and quitting. They're always running. You don't turn intelligent agents on and off. They're always running. They're always thinking. They're always processing. And an agent doesn't need the user's input to function, because it's already thinking like a human if you do it right. Now I'm going to give you an example in a little bit about how an intelligent agent is helping the U.S. military. How does this work? Well, one proven approach for emulating human decision making is called the URU. How many people have heard of the URU? One. Very good. Developed by Colonel John Boyd, U.S. Air Force. Fighter in the Korean War, trainer during Vietnam. Colonel Boyd reasoned that in a dogfight, what you're doing is you're doing 4 things. You're observing, you're orienting, you're deciding, and you're acting, and you're doing that over and over again. And his basic premise was that if my OODA loop, my decision cycle, is faster than yours, and we're in a dogfight, I'm going to win. And he institutionalized that as a concept. It's now been used. It's used to train all pilots. It's actually now being used to train a variation to train paramedics, because it's great for anybody dealing with a lot of data, urgent time pressure, a lot of variability. It's a thought process. This is what we do anyway. It's how humans think. And by the way, Colonel Boyd was also known as 42nd Boyd during During training exercises, he's got anybody, $100, he'd let you get on his 6, and within 40 seconds, he'd be on your 6. Never ever lost a bet. Colonel Boyd then became a strategist for the United States military, and he was one that came up with the strategy of the big left hook in the first Desert Storm operation, and he died shortly after that. But he came up with this idea that basically documents what we do all the time. Right now, all you folks are observing data. The data's going to your head. You're oriented. Some of it's sticking, some of it's going out. At some point in time, if it hits a threshold, you're going to make a decision. And when you make that decision, you're going to execute. And you're going to do that over and over and over again. Thousands, tens of thousands of times a day. That's what we do. What we've done is we have codified the OODA. So we have an observant-oriented graph that involves sensors, which are inputs, beliefs, which are thresholds, monitors, which are monitoring, and then we have a decision graph that involves goals and plans and actions. And these are called, if you want the fancy term, they're called acyclic graphs, because they really don't have a start and stop. They just constantly are going. Remember I said intelligent agents don't start and stop, they just keep running. So you'll see we actually have visualized these graphs, and if you look at our computer screen when an intelligent agent's running, all these things are blinking up, you have lines going across and all of that, because I can make a decision and an action that changes my environment, that forces me to make a different decision, right? We do that all the time. So, my original background, my undergrad at John Motors Institute out of Flint, Michigan. And so I come out of Michigan, I'm a car maker. And even though I spent 30 years of my career in technology, at my heart I'm still a car maker. You come out of Michigan, you're still a car maker. You talk about cars, you like cars. So this is my attempt to explain how an intelligent agent works if an intelligent agent was running a transmission. And by the way, in many ways they're starting to put intelligent agent technology in transmissions. But remember I said there were 6 things. There were sensors, beliefs, monitors, goals, plans, and actions. We build entire intelligent agents that support a military campaign or hospital effort based on just those 6 constructs. So sensors, I'm inputting, I'm receiving temperature, RPM, pressure. I believe when my RPM hits 4,000, I should shift up. I'm going to monitor it so that I know when I hit 4,000 RPM. And when I do, my goal is to shift to the next higher gear. I'm in 3rd gear, I'm going to 4th. I'm 4th, I'm going to 5th. My plan is, when I shift, I will increase the fluid pressure between the flex plate and the torque converter, and I will increase the speed of the impeller faster than the turbine, and blah, 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 blah. I used to design engines, so you gotta, I'm an anal retention recovering engineer. I apologize for that ahead of time. And then the action is to actually execute the plan. That is an intelligent agent running a transmission, and that is how it thinks. Does that make sense? But that's what you would do as a human, wouldn't you? Remember, one of the things I'm going to tell you right now is particularly intelligent agents have tremendous power, but there's nothing an intelligent agent that it does that a human couldn't do if a human had perfect information in unlimited time. But we don't. Virtually every industry's big data can benefit from AI. In the world of finance, hedge fund trading, looking at transactions, looking at illegal foreign transactions on a very high-speed basis, that can be handled with AI. Hospitals and medicine, both on the billing and coding side, which I'm going to give an example of, as well as on the clinical and the diagnosis side. Heavy industry, robots are being used throughout. Transportation, telecommunications, obviously toys and games. I was blown away. I heard a statistic last year when it was the new, the only online games I play is chess. So I know it makes me a nerd, but when I take breaks, I play 3-minute blitz chess with people around the world. It relaxes me. But I've never had the time and patience to sit there to play a game for 2 hours like my sons used to do. And eventually they actually grew up and had a good job and can't do that anymore. But Call of Duty came out, and they said in the first 2 weeks that generated more revenue than every movie that came out of Hollywood during the preceding 12 months. I was just blown away by that statistic. It has absolutely nothing to do with what we're talking about, but I just think it's a neat statistic. Okay? Music can be used. I already told you about what it's doing with Spotify, Pandora, iTunes. It's identifying what you like to listen to and giving you more suggestions. I mean, look at Shazam. Shazam is an AI application. It listens to music, encodes it using a neural network algorithm, and then identifies other music that has that same type of frequency and speed and tempo and highs and lows and all that. So let me walk through some examples. I got about 15, 20 minutes, I think. This all, nobody's fallen asleep yet, so that's a good thing, I guess. You'll find this interesting?
Are you going to handle presentation somewhere we can download it?
Yes, yes. And by the way, if you take this presentation in Starbucks for $4, they'll give you a cup of coffee. Trust me, it works. I tried it. So one of the things that this company really got its name from, VELOXITI, and again, we used to be Applied Systems Intelligence. We rebranded the company in the fall of 2011 because I wanted to designate a new company with a new business model, no more research, but more development deployment. But the Warfighter Associate was focused on helping a military commander. Warfare is becoming increasingly more difficult. One, there's a lot more computers out there. Eventually, when you sign up for boot camp, they're going to give you your dog tags and a little Android battle phone. That'll be with you everywhere you go. And that would have an AI agent on it. We actually now have an intelligent agent system running on an Android phone. Okay? They're talking about asymmetrical warfare. That's a fancy term for urban warfare. The old days of putting two opposing groups on a field and going at it are long gone. Asymmetrical warfare, if you're dealing with urban environments, you're dealing with inconsistencies, you're dealing with a lot of variability, it's extremely difficult and it's dangerous. And one of the things we do is I was brought in to take this technology into commercial space, but with the same sense, I am so proud of what we do, because what we do will save American lives. And I'm going to give you examples. Humans can't process all the quantity of speed, so this warfighter associate emulates the perfect commander. So what we did, and we started small, it's kind of like making a baby at a very high level. We made the intelligent agent, it was maybe a toddler. If that, it was just a baby. You touch its cheek and it smiles and it says, Mommy and Daddy, and it does a few other bodily functions. And then we train it and we educate it some more, and then some more. And just like you would like bring in a new employee, if you're going to bring in an intelligent agent to help your employees, you keep training it, you keep developing it, you keep educating it. Because the smarter it gets, the more beneficial it is. Warfighter Associate right now is probably on its 14th iteration. So what this Warfighter Associate is, if you're a military, you're a full bird colonel sitting in a battalion headquarters, you're responsible for 5,000 soldiers, all their air assets, all their ground assets, helicopters, fighter jets, unmanned drones, Humvees, tanks, supply vehicles. You're also responsible for knowing all the areas of operation, all the orders of the day. And oh, by the way, you're supposed to have the entire Universal Land Warfare Manual memorized, as well as all the battle drills. That's your job. Now, the reality is, in the military, there's not a lot that gets communicated via radio. It's via chat rooms. I can't tell you how many, but just assume there's thousands of chat rooms associated with the various military agencies and the intelligence community. So, as a human, we can maybe monitor 5 or 10 chat rooms. So what you do as a military commander, you kind of take what you think are the 5 most important, and you ignore thousands of others. So what happens, let me give you an example of how this works. So we have built a little intelligent agent, actually it's an associate. This is our definition. It's not really a standard definition of the industry, but I'd like it to be. The difference between an agent and associate is the following. Agent is a closed loop, standalone intelligent agent piece of software. Associate is nothing more than an agent with a human in the loop. They don't want the computer to push the button. So we deal with both associates in the military. We also deal with them in healthcare. They want a doctor to make a final call. Other types of applications, it's not life or death. You may just work with agents, not associates. So this warfighter associate, we built one for the commander, and it knows everything that's going on. It's got the entire Universal Land Warfare Manual. It's got the orders of the day. It knows the performance characteristics of every vehicle. It knows where every soldier's at. And you're in Kabul, Afghanistan, and you tell a young lieutenant in charge of platoon, hey, look, there's this apartment building, I want you to go to check it out. It's going to take them about a half hour to get over there. So you forget about half hour, and you're a great commander. It was a valid order. You had good reasons to give that order.
About 29 minutes later, all of a sudden, our intelligent agent kind of electronically taps you on the shoulder and says, hey, Colonel, we thought you'd like to know. The NSA just posted an intercepted phone call in chat room 4273 mentioning your platoon and that address. You might immediately get on the radio and say, Lieutenant, do not go in that building. You're walking into a trap. I'm cording it off. I'm staying in reinforcement. That's what an intelligent agent does. It does nothing more than the commander could have done if the commander could have stopped time and looked through all those thousands of chat rooms. But the humans can't. We do certain things very, very well, other things we don't do as well as a computer. So we've combined computing technology with human thought process, and that's what this intelligent agent is. One more example. So now you got this thing called a TIP, troops in contact. Somebody is shooting at American soldiers. That's important. That takes high priority over everything else. So immediately you're looking at your screen, and that's what you're standing at, and all these computer screens and stuff like that. You're looking at it and say, oh, I got a predator right here, I'm going to retask it. Our intelligence agents say, Colonel, don't do that. You have an A-10 Warhawk, which is another type of aircraft, manned aircraft. It's 5 miles further away, but it's faster, so it can actually get there quicker. It's got better optics. And what you don't know, Colonel, that we know, we being the intelligent agent, is that that predator right now has been surveilling a house for the last 36 hours with a high-value target, and tonight special forces are going in there to take care of the situation. And if you pull that predator, they'll scrub that mission and we'll lose that high-value target. So that's what our intelligent agents do. And now what we've done, for the first time ever, you've got all these different roles you'll hear in the military: S2 officer, S3 officer, S6 officer. It's ops officer, intel officers, logistics officer. It's fire control officers, communication officer. They don't have time to talk to each other. But now we've built roles for each one of them, and now all of their little intelligent agents are talking to each other and letting their human know when there's something that they need to do something about. So our intelligent agent in this application does two things. It provides prioritized situational awareness data. That's in Kernel. There's about 10,000 things you can know right now. Here's something you need to know about right now. And it also provides recommendations based on the fact that we've got the Universal Land Warfare Manual in there. We've got the battle drills. We have perfect information. And we also have built in the knowledge base of some of the very best military commanders. So that's a military example, but does that help you understand how an intelligent agent is working? Now you can apply that to a hedge fund trader. A hedge fund trader is going to look at 10 different sources of information before they make a decision. We're saying that's all you can do in that time period is look at those 10 pieces of information. But why don't you let us take a look at 1,000 or 2,000 or 10,000 and come back and give you the 10 that are most relevant to the trade that you're about ready to make. And we can do that in healthcare and stuff like that. So that's one example. Another example is a pilot associate. And the reason I bring this up is that I just, at Clemson University at the it's Clemson's University International Center for Automotive Research. We're talking about working with them. We're doing vehicle control and vehicle management. But we were working on Pilot's Associate, and basically what this does, it helps a pilot improve the situational awareness, reduces workload, provides better decision making. If you take a look at the cockpit, starting back in '88, the avionics on a fighter jet have become so complex, even in a commercial airplane, that it's difficult for a human to scan it all and really figure what's going on. Now, if you talk to military pilots, and I've talked to a lot of them, and obviously if you ask them who's the best pilot you ever saw, they'll say you're looking at them. They've got to have that confidence. They've got to have that ego, and I've got no problem with that. So early on, you put a pilot's associate on a plane, and he's got one bogey behind him, and the intelligent agent says, hey, Mr. Pilot, or Mrs. Pilot, would you like me to fire off some chaff? He says, yeah, no, actually, I'll fire the chaff. Next day he's up, and he's got 2 bogies behind him and 3 in front of him, and says, you want me to handle the rear? He says, yeah, take care of that because I'm busy on the front. That's called bounded autonomy. So depending on the situation, we give the intelligent agent varying levels of autonomy. Now we're looking for semi-autonomous vehicle control. What's the value of that? Maybe you only allow an intelligent agent to take the car up to 20 miles an hour. But if you've got 10 cars at a stoplight, and we've all done this. In fact, we do it all the time. I was on Georgia 400 today with about 10,000 of my closest friends. And what happens is, when the one car starts, there's a lag, and the other one goes, and the other one goes. You've seen this, right? It happens all the time. So it happens even when you're driving home tonight. If they all had intelligent agents, guess what? All 10 cars could start at the same time and move through. Think about the fuel economy. Think about the time saving. Think about the traffic congestion reduction. So that's some of the things we're looking at, using intelligent agents to process all this information and make decisions. Healthcare. I promise I will not talk or critique the Affordable Care Act. Being as a CEO with my healthcare costs going up 57% next year, I've just been struggling with the word affordable. I don't know where that came from. But healthcare has become extremely complex. I mean, you know, and again, I say it facetiously, but even, you know, Nancy Pelosi said, well, we have to pass the act before we figure out what's in it. Nobody's quite sure what's in it. They're not even quite sure how it's going to work. It's extremely complex. There's an exponential increase in the rules and the regulations. Humans can't keep up. And plus, there's a shift in the coding system. So today, when you go see a doctor, you're going to hear two terms, ICD-9 and CPT-10. So the ICD-9 is what the doctor, is a billing code, when the doctor writes down all his notes. A coder later on will look at that and say, he diagnosed you with this, this, and this. Each of those have an ICD-9. And oh, by the way, he prescribed this, and he did this, and he did this. Each of those have a procedure, CPT. That is how the world gets paid. 70% of all the world's healthcare payments have an ICD code associated with them. Okay, it's used overseas. Part of the problem is, in this country, we're at ICD-9, about ready to go ICD-10. We were supposed to go to ICD-10 10 years ago, and we haven't. Europe's already on 10, about ready to go to 11. Now, what's the problem going from 9 to 11? Well, 9's got about 16,000 codes or something like that, and 10's got about, I think, 68 or 70,000 codes. Every healthcare professional, just think of the complexity just placed on them to try to do all this coding. We've already built a prototype of an artificial intelligence entity that reads the doctor's SOAP notes in natural language processing techniques, analyzes them, and applies the codes automatically when we have a human do a final review. But it saves the human about 90% of the time normally. So it has an application there. Associative memory. This is very powerful. This is an example in the diagnosis of breast cancer. Is a technician will come in and early on will take the samples, and based on these characteristics will say this was present, this was present, this wasn't, this wasn't, this wasn't, this was, and then make a conclusion whether it was benign or malignant. And you do this enough, we have now an associative memory system that starts taking all this data, starts processing it, and now it can dramatically reduce the time it takes to do a diagnosis, because if somebody takes a look at all the lab data and it knows what the situation is. That's just examples, and again, later on, you know, questions like that, I can give you more if you're interested in things like that. But what's the future of big data and artificial intelligence? And again, this is just, you know, our perspective. But, you know, we live in interesting times. Big data is touching everything, and AI is beginning to touch big data. That's what we talked about. Key trends in big data, it's going to get bigger. You get what you pay for when you hire me. You didn't pay me anything, so I give you that great insight, right? Okay? Big data is going to get bigger. But guess what? Commercial will have to drive some type of financial value. At some point in time, people are going to say, you just spent last year $20 million on big data. At some point in time, show me the return. Going to focus on more diverse data, just not more. Instead of collecting a lot of data like this, collect a little data here, 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 and let the intelligent entity figure out what it means and identify the pattern. Data visualization will merge man and machine. We have a phenomenal ability to look at some graph. They say a picture's worth 1,000 words. It's worth 1,000,000 words. Humans have the ability to look at something graphically and come to conclusions using our brains, our thought process, our fuzzy logic that computers have a heck of a time doing. Okay? As we do a better job of data visualization, we're going to be able to marry this man-machine interface even more. Let the machine go through all that, provide the visual, and the human says, this is what we should do. And focus on data immediacy for better prediction. I mentioned earlier, you know, I can predict something better if the data all happened in the last minute versus a year ago. Key trends in artificial intelligence. It's going to move to front page news. You'll hear about more and more about it. You're hearing about it now, but you don't see it because you don't know that AI is behind that technology. But as you get more things like Watson, people will say, oh, that's artificial intelligence. It will move from custom configured. Right now, everything's a one-off homegrown application. There are a few development environments. We're one of them. I think we're the only true commercial one. Most of them are associated with universities. But, you know, our idea is to provide a development environment so that other companies can develop their artificial intelligence. DOD will continue to push the envelope. DOD's been pushing artificial intelligence for a long time. There's things going on in the DOD that are absolutely amazing. Well, this is Sprint, so you guys do network configuration all the time, right? Think about the communication officer of battalion headquarters. Think about the networks he has to create every day, not just once a year, not once a month, every day. You got a platoon going over there on that part of town, he's got to create a communication network for him. You got a company going over there, he's got to create a communication network for him. And he's got to figure out, like a standard Humvee vehicle will have 3 computers on it, and then one battle tank will have, 6 or 7. Everyone's got its own IP address. Plus you got the computer and the communication device that the platoon leader is carrying and all that. So it's a nightmare. What we've done is we've developed, and the government paid us to do this, we've developed an environment where you graphically grab a Humvee, a tank, a helicopter, a platoon, and you connect them the way you want to connect it, hit the button, and it configures a network like that. So that's some of the stuff we're doing. And by the way, what I love about it, I mentioned, we do most work with the government. I'm a technology guy. I worked a little bit with gas turbine engines back in my 20s, but most of my career has been in commercial technology. But the only thing I understand about the government that I really, really like is they keep giving us a bunch of money to develop stuff that nobody else in the world has got, and we still own all commercial rights. So the government pays us to develop it for them, but we own commercial rights. And commercially, you continue to utilize point solutions. Again, very specific AI applications. Your phone, your car. We're already seeing a brave new world. In 2009, Adam discovered scientific information on its own. Adam was this room-sized computer, this artificial intelligence entity that was looking at the genomics of baker cheese. There's a fancy Latin name I was going to put in there, but I couldn't pronounce it anyway, so I left it out. But it's an organism that scientists use to model more complex life systems. What Adam did is developed its own hypotheses, determined its own experiments, ran the experiments, and came to its own conclusions. That was groundbreaking for 2009. Google, this just came out a few months ago. Google had a system that invented its own concept of a cat, and then by looking at 20 to 25,000 images, eventually determined what a cat is. It did it on its own. Nobody gave it a little head start, a little tip. It determined what a cat is. Now, by the way, a kid could do that in a few seconds with our brain, because of our ability to do pattern recognition. But that's big. And by the way, what I love about it, Google's not even sure how it did it. They're not even sure how the computer they built came to the conclusion that it did. So artificial intelligence is alive and well, and it's real. It's not science fiction anymore. Boston Scientific Cheetah. If you ever want to see something really cool, go off to YouTube and type in Boston Scientific, and you can do Big Dog. It's got some great videos. Cheetah's got some. Big Dog can carry about 250 pounds, but it's basically, it looks like a headless donkey that's going through there. But Cheetah can run 25 miles an hour, jump over a 4-foot fence. It's self-balancing. They put it on ice, water, hills. It doesn't fall over. It can collaborate with each other. One of the projects we did about 3 years ago is we had 3 robots, Huey, Dewey, and Louie, that we were developing a system where you'd send them out onto a patrol, and they interact with each other in terms of what path to take, what to do, and only call the human when they need to. Again, bounded autonomy. And we call that multi-collaborative robotic systems. Ruby. You have a social robot that reads a child's face and reads the expressions of behavior and interacts with the child depending on how that child is feeling. Robotic factory workers, they can handle many stationary tasks where it's a lot of simple stuff. They can also handle very complex. Now you see these big robots that are in commercials doing all the painting, around the body in a car commercial. A human can't do that as quick. You can't do it as well. One of the neatest things that we see is this thing called labor force multiplication. So the example I gave you before with the battalion commander can only look at 5 chat rooms, and there's thousands of chat rooms. We basically didn't replace that commander. We simply took part of their thought process that was data intensive and put it on uber speed via artificial intelligence. So we took part of their thought process and multiplied it thousands of times. Well, I suggest to you in any business, if you take a look at the population of the workers, and this gets skewed one way or the other, but let's say it's somewhat like a bell curve. There's always a percentage of high performers or your high pies. And in general, most companies, whether it's insurance underwriting, hedge fund trading, in many ways, they're going pay for performance in the medical field for doctors and all that, is you get the bulk of your performance, whether it's your revenue or margin, from the high performers. Agree with that premise? That's not what happened. Well, what can we do? What we can do is we can take the intelligence and how these high performers think about underwriting a loan, or doing a trade, or performing a medical procedure, or making a military decision. Build intelligent agents that we then have sit electronically on the shoulder of all the other people, and we can basically improve their performance, take a C worker and turn him into a B into an A. We shift this curve, and that performance goes up. And that is real. Those are real dollars. That's real time savings. That's real benefit. And even more than that, remember the high performers who said there's so much big data that even high performers are being inundated with data? Right now we saw that one of the statistics I saw was for every key decision, major decision made, a worker would typically spend anywhere from an hour and a half to 2 hours to get the data and figure it out. Sometimes it goes longer. Well, with artificial intelligence, what we can do is we can help even these people and increase their performance. We can take even your best performers. Like I mentioned to you, your hedge fund trader, he's your very best hedge fund trader. He says, look, I like to look at these 10 types of data things when I make a hedge fund trade. We're saying, great. Let us sort through a bunch of stuff. You keep 2 or 3 that you just really always like. And we'll give you 7 others that are better than the 7 you're looking at. I'd love to give you an example. We have the intelligence committee right now, but it's along those lines. AI is going to continue to leverage big data across multiple applications. So here's a bunch of typical standard AI applications and others. You know, everything from artificial intelligence and natural language processing. Again, 90+% of the data, and it's going up even more across the internet, unstructured data. But pattern recognition right now we're looking at people's Facebooks, and we're seeing in the picture of Facebook they're wearing Nike tennis shoes, and now I'm going to create a marketing campaign for that person based around Nike tennis shoes. That's all happening, and it's happening in an exponential way. And AI will be driving the results of that. I love this quote by Winston Churchill: the empires of the future are the empires of the mind. I've spent my entire life in high tech. To me, the technology is the beautiful thing. To me, it's been looking over the horizon, identifying the macro trend, identifying how to change what somebody does with the voodoo you do. Having been around the technology game for 30+ years, I've come to the conclusion that you can imagine it, somebody will figure out how to build it. The trick is how to imagine it. So as you look at big data, and you read about it. Now, hopefully I've given you a little bit different perspective when you read the papers and you start to see stuff, and you see things that companies are doing, and you say, you know what, I bet you some artificial intelligence behind that. I do it all the time. I read it, but I know what I'm looking for. I'm hoping you can start to see some of those. So, at a very cursory, that's the role of artificial intelligence and big data. And with that, I'll take some questions if we have time for them. Yeah.
So, as I understand that, I wasn't familiar with VELOXITI coming in, but it sounds like one of your products is a development studio.
Yes.
With that, but it sounds like a lot of the exciting projects you told me about doing DoD and everything. Is your development studio, is that a play, sort of like an open source play to drive AI innovation across the market, or what was the...
That's a good leading question to our new marketing strategy.
Okay.
So in 2014, what we want to do is, when I first got there, I came to the conclusion technology was not scalable, was not deployable, was not robust enough. And plus, I couldn't take 9 months to train. I mean, the number of people that truly know how to build an intelligent agent in this country, you could take a high school basketball team and have room for the volleyball coach. You need 400 or 500 people. And to me, I don't want that market. So that's why we moved it from C++ to Java and built this GUI development environment. And we've proven this now with the U.S. Army. After 3 days, U.S. Army Java programmers are building intelligent agents. So yes, we have this development environment we want people to start playing with. So what we're going to be doing, we hope to have it done by the end of the first quarter, is we will have 3 different versions. We'll have a free version that you can download and start learning how to do intelligent agents. Okay? We'll have another light version that's got additional functionality that you pay for, and then we'll have the full version. So that is our strategy in 2014. It took me, I feel like I'm 18 months behind because when I came in, I didn't realize how badly we needed to redo the technology. So, I mean, you should see my head of engineering when I went to him in November of 2011, says we have to rewrite every single line of code. And after he picked himself up off the floor, him and his team did an amazing job. Like I said, I got amazingly smart people working, and it's an honor to be working with you. Did that answer your question?
It did. And then a quick follow-up, do any of those smart people contribute to any of the kind of the Apache top level, like Mahalik or anything like that?
Right now, we are actively involved in offshoots of the college associate for rotary aircraft. That's all I can say. But yes, it's one of the things I can say, because this was written up in a BAA, which is a broad agency announcement, that anybody can on the web look at it, is right now, for the Army, it's not necessarily true for Marines, but for the Army, all these drones flying over Afghanistan are being piloted by somebody sitting back in California. There's a time delay, there's a lag, they don't have the same situational awareness, they can't see what the human can see. So we are actively building a system where the co-pilot of a Cobra can manage 4 or 5 drones at the same time himself, which means that each of them has to have a certain level of autonomy, because you just can't fly all 5 of them. So you got to be able to send them, they got to have certain, performance envelopes they do on their own. They coordinate with all the other drones to cover an area and optimize it. They do it faster than the human can. But the human can say, I want you 3 to come up with a plan and go over in that area. So that's something we're developing right now. And by the way, a lot of that's why Clemson University wanted to talk to us, because what we're doing with the Pilots Association is exactly what they want to do with automobiles. And they really are moving towards having cars that, once you're on the expressway, you hit a button, take your hands off the wheel, really work or something like that. Yes.
Do your agents learn from experiences?
Intelligent agents, by definition, are not self-learning. Neural networks and social memory are. However, if you put the term, they're built on Bayesian belief systems. The probability of A and the probability of B. Okay? So there is a Bayesian table. What we do is, as it makes decisions, it looks back at its decisions, it learns, comes back to a human and says, we'd like to update our Bayesian table based on conditions. The human has to approve it. But we have built a self-learning piece into an intelligent agent, which is pretty leading edge.
And is that based in any way on reinforcement learning or inverse reinforcement learning at all, or is it completely different technology?
It's a form of reinforcement technology in that we're looking at a situation, a decision, the outcome, and then we take a look at enough of those and say that that's something worth being reinforced. But again, especially with these military agents, they're very leery about learning bad knowledge, so they always have, it has to go through human before they allow it to learn.
I'm curious about this industry, like artificial intelligence.
I'm sorry, I got old ears.
So I'm curious about the industry of artificial intelligence from business perspective. So if we're talking about these technologies, and we see that they are spreading apparently pretty fast. So what still are barriers you see in your work of this technology being spread very rapidly? And what are limitations, restrictions for this technology?
The question is what do I see as the barriers to AI spreading and evolving even faster and getting greater traction? The biggest one is it scares people because they don't understand it. The traditional selling model in AI world is, hey, look, I got this car. It goes 0 to 60 in 3.8 seconds. It's 80 miles a gallon. Well, let's go tear apart the engine. I'll show you how it works. Our philosophy, just like Google, Google's the largest AI company in the world. They don't advertise AI, but it's part and parcel of everything they do. I got a car that goes 0 to 60 in 3.8 seconds. It's 80 miles a gallon. Let's go take it for a drive. Later on, if you really want to know details, I'll tell you how it works. Okay. One of the biggest things, and this goes offshoot. So in 1984, I was one of the pioneers in high-end computer simulation modeling. So, does anybody remember the original movie Tron? You do? Okay, cool. They used to do that, by the way, on these big Evans and Sullivan PS300 vector boxes, size of a refrigerator. That was my demo box. I had a special van. That's what I had to go around and demo with. But I took everything east of Mississippi and was building a company, And what we did is we took that technology and applied it to the design of large-scale factory automation systems. General Motors, Ford, Chrysler, they're building a $400 million plant. And when you're just using conveyors, synchronous systems, you can use standard queuing theory and statistics to figure out what you're doing. But then they started using these things that have variability to automatic guided vehicles, thinking it's an automatic fork truck, automatic storage retrieval systems, service with power and free systems. All this variability, things could switch in dynamics. You couldn't use statistics anymore. You actually had to simulate it. But the problem is the people who did the simulation, and I was a systems engineer, is you'd come in with a 2-inch stack high of green bar paper and talk about confidence intervals and queuing limits and things like that. And the engineers designing a system, just their eyes would cloud open. What changed the game is, and again, I'm very fortunate to be part of this company, is we were the very first company that took the technology from Tron and applied it to the design of large-scale factory automation systems. And we could actually, because we used the control algorithms from the actual vendors themselves, we could build a computer model inside a computer, three-dimensional. You can see it. You can fly around it like your little helicopter. See the cars being assembled, see the robots moving, and we could predict the entire factory's performance to within 3% before it even go. In 1987, for 2 hours, I sat next to Lee Iacocca and let him do that. He was having a blast doing it. He wanted to fly with a brand new Liberty plane. So one of the things we did is, and by the way, 95%, probably 100%, but I try to use 95% because nobody believes 100%. But 95% of all my proposals were sole source because nobody else in the world could do what we were doing. That visualization took this very real technology and brought it so people could see it. What I'd suggest to you, when we talk about these object-oriented or reserve-oriented graphs, the SIGNAT graphs, what we've done now is we had a general, and the Army paid us to do this, that we build these graphs with all these boxes. What he paid us to do is say, look, I can't argue with it, it seems right, but I actually, if I'm going to put this in a battlefield situation, I need to see how it works. So he paid us to animate our graphs. So you can actually see how an intelligent agent is thinking. And by the way, that's one difference. So an intelligent agent is a white box. You know how it's thinking. Neural networks, by definition, are black boxes. A neural network system will tackle the same problem, the same data on 2 different days, get to the same answer, but take 2 different ways to get there. That's just the nature of what they are. So they're black boxes. So I think one of the things that will help, several things will help AI come to the forefront. One is the visualization, that you can see it. 2 is for people to realize companies like Google, there's AI all over the place. And companies like in the healthcare field, we're talking healthcare companies right now that are taking it, but they have to recognize the problem, they have to be visionary thinkers, because this is not incremental change stuff, this is game changer stuff. This is big stuff. And I tell people, you don't sell, you educate and enable. Say, if you want to try this, we're here to help you. Okay? You can be a follower or you can be a leader. The old days and the old rule of thumb was in the technology game, and a lot of us with, I look around a few great years, the old rule of thumb is you didn't want to be first in the marketplace because you got the arrows, right? That's no longer true. This world is moving so fast with technology, with information, with communication, with markets, is the secret is to get into a market, be the leader, make money, and get ready to change because it's going to shift again. So I think those kinds of things will help bring AI to the forefront. I'm hoping so, because I'm supposed to be responsible for taking this company in the commercial marketplace. That's what I'm hoping.
But you see that the fear is the root, and people are scared of this technology.
People are always scared or concerned about what they don't understand. And right now, I'm waiting for about another 12 months of CEOs writing out checks for millions of dollars because their IT department and their marketing department, by the way, right now in this country, marketing technology budgets are higher than IT budgets. But I'm waiting for them to say, where's my return? Then we can come and say, we're not going to get a return. We start applying some intelligence to this data to make some sense of it. But yeah, there's an education piece. It's new technology, and there's always an education piece. Any other questions? I'll stick around for a little bit if anybody wants to talk or wants any other. Yes?
I have another one.
No, go ahead.
It's so exciting, I believe we're all convinced right now, but what do you see bad about this technology? Say, if we implement them and they work the way they're supposed to work, but it's still harmful for people, for environment. So
What's the bad side of this?
Yeah, like bad.
Several things. One, as a human being, if you're not willing to adapt, learn, and change, you're going to be left by the side because the computer's going to take over your job. That's the reality. Or it's going to ship you overseas. Okay. Two is, it's like, and even though it's changing, you know, I've got a boat, and they say, you know, every captain should know how to work a sextant in case your GPS system stops working. I don't know how to work a sextant. I have a backup GPS system. Okay. This will take certain cognitive processes and probably degrade them a little bit in terms of how we think about stuff, because we won't have to anymore. Right now, I understand schools are not teaching cursive anymore because they just don't use it. People don't write anymore. I know. Yeah, when I had that simulation company in the 80s, we had a list of about 1,000 phone numbers. I batted about 700. They asked me one of 1,000 numbers. I had it. I couldn't do it now if my life depended on it. So I found to remember my own number. But so the negatives would be is, and again, people are scared we come in, especially when I talk about that labor force multiplication. The idea is that, look at labor right now is the pain point for executives. I'm a CEO. Labor is going to be the most expensive. It's with the Affordable Care Act, it's going to be increasing even more. You're going to have to provide assistance to a great number of employees, because right now, what people don't realize, all these people that voted for this administration, I hope they realize this, is that the reason you're not going to get, unless you're in a highly skilled position, you're not going to get a 40-hour-a-week job. You're going to get 24 hours. You know why? Right now, it's going to be better and cheaper to hire 100 part-time workers than 40 full-time. And that is the very nature of what we create in this country. Okay? If I have people only working 24 hours, I can't spend as much time training and things like that. For some of the things that I really want them to monitor, an intelligent agent can really help and benefit them. That's not a negative, that's a plus, but you know, I think the biggest thing is how it's going to impact labor, and how it might impact some of the cognitive abilities. But then at the same time, if, you know, I had a graph I didn't put on there, if normally, you know, if I take a look at the complexity, and I'm with the graph view, complexity is in the y-axis, and the x-axis is time. And I'm going to make a decision. I observe, and I orient, and I decide, and I act. But with an intelligent agent, they can observe and orient like that, and then I decide that. I can take this decision cycle and make it like that. Does that make sense? So that's what the potential is. Great. Anything else? Like Dallas, yes.
Okay, well, the audio we are talking about is just a couple of let's see. They call the thing AI, which you do not understand what the solution is, but understand it is figure it out, they call it algorithm. What do you think on that?
On audio AI?
No. If you do not understand the problem, how to solve it, we call it AI. Then if you know how to do it, then we just call it, well, it's a just simple algorithm.
Yeah, okay, so the question is if you know how to do it, why don't you just program a simple program rather than using AI? Where AI is particularly good in environments where there's a lot of variability, very critical decision making, a lot of complexity. So what happens in normal programming we call a rules-based system. As rules-based systems get bigger, 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 they start to become brittle. I touch something here, something over here breaks, right? Now I know none of your code's ever had a bug like that, but I heard a few people talk about bugs. But that's what happens in normal coding. Intelligent agents, you can as big as you want, and they don't have all this interconnection because they have a very flexible framework in terms of sensors, beliefs, monitors, goals, plans, and actions. So in some cases, it's still going to make sense just to hard program it. But in other cases, it will make sense to maybe take a hard program, but then put a little bit of intelligent agent on top of it to handle this part. We're right now working with a company that is using something called the moral foundation theory. So right now, most B2C companies go out and analyze all the consumer data and try to identify what you're going to do based on what you've done. The moral foundation theory, developed by Jonathan Haidt, says it's based on a few demographics from you. We apply about 300 characteristics of varying levels of probability to you on how you think, how you feel. And it's not based on discrete purchases. It's based on where you were raised, your education, how the country lives, your value system, what's happened to you lately. You got married, you got divorced, you had a baby, you bought a new house. All those things will impact your decision making. And with moral foundation theory, now what they've got is this neural network to do all this, and we're putting our intelligent agent stuff on top of it to orchestrate all this complex cluster analysis. But now what they can do is they're showing, they've already proven it to one Fortune 500 company, it's a brand new company, not the Fortune 500, but the company we're working with, that we own a small percentage of, is now they can not only do a better job of predicting your decisions, but now they can actually do a better job of influencing you. Because I can have the same exact sales pitch, give it to you, and you. You like it, you think it's the biggest power horse minority you ever saw. So you got to know, as marketers, you got to know how to talk to your people. And that's based on what they're made of, that's the moral foundation theory. So we're actually codifying the moral foundation theory. So now we're doing is we're integrating behavioral science with artificial intelligence for consumer marketing.
And also on the human decision making, well, human usually has the habit of making a decision first, and then rather than supporting the evidence.
Well, what humans are very good at doing is establishing hypotheses and testing hypotheses. Yes. And what we do is we build that in when we build our intelligent agents by interviewing the very best, like military commanders or doctors or whatever. We identify those things that they make assumptions on. And that becomes part of the belief system. Because again, a belief doesn't mean it's right or wrong, it just means you believe it. Yes.
Just about the decision validity.
I'm sorry?
The validity of the decision made by AI. How do you validate it? Like when you suppose I have a system, I just.
Or how you validate it?
Yeah.
Well, I'll tell you what we've done, the best example is U.S. military, because that's what we've done most of. So we have this warfighter associate that's sitting in the battalion headquarters. They have the Army Research Labs at Aberdeen Proving Grounds in Maryland. And we've had over, now it was 300, now I think it's about 500 officers, general officers, colonels, majors. Take a look at the situation. Take a look at what the Warfighter Association came out with. And to this date, they've not been able to find a single thing wrong. Because it's modeled off, it's modeled after the Universal Land Worker document.
For any system, when you first establish it, there will be human seed. What I see is the human seed which will be comparing against and making sure your AI is okay.
Yeah.
And going forward, it can become more effective. Given the time is more data.
Yeah, you can. One of the things we did, by the way, with the system is now they're using it for training. Because now if you're a commander, now what they do is they have an intelligent agent sitting on your shoulder, but they tell them to go quiet. So it's mute. So it's paying attention to everything you're doing, and what it does, it measures your response time to a situation, the decisions you made, the quality of your decisions later on, gives you a performance report in terms of how you as a human performed against the perfect standard. So that's how we measure it, just how we're using it.
We as humans learn because we have emotions. For example, when we get scared, we learn the situation better.
To touch a hot plate, I realize that's hot.
Yeah. So, and that's how we basically learn from the experience. Do you think, or maybe for all this artificial intelligence technology, do they have or will they have some sort of emotional piece that will help them to learn better? Or
that is the most difficult thing to do. In a very primitive way, they are working on doing it right now. And like, for example, one robot that looks at a face and can determine the mood of the person, based on the face. You're absolutely right, and that's probably in the most primitive stage of all the different elements of the world of artificial intelligence. Yeah. With each other, you mean?
Yeah, they cooperate with each other and they create emergent behavior that is not being programmed. You see, when you have research cases and you have the solution, you see that as an emerging solution.
Well, it's definitely, it's what we're doing with the UFP systems. I mentioned with the helicopter co-pilot associate. It's what we did with our 3 robots a few years ago, really movie. They talked to each other and they made decisions on what they were going to do. But they had bounded autonomy. We said, your mission is to do this within this frame. If any of these certain things deviate, contact your human. I mean, a squad in the future won't be a platoon leader if it's humans. It'll be a platoon leader, 2 humans to be 4 robots. I mean, right now, if you take a look at Cheetah, or the Cheetah can run 25 miles an hour. Now, the military has these things called cave cleaners. The robots with a big machine gun, and they send them to the cage, and they take care of the cage, okay? Without being too graphic. But you can imagine being some terrorist in a valley in northern Afghanistan and having a 25-mile-an-hour metal robot running down. They're starting to coordinate that. They're going to be able to partition off and be able to, and again, they do this because we're keeping a human, an American soldier, out of harm's way. But the idea of robots interacting with each other and developing emergent behavior, it's already happened individually with that Google system I talked about, as well as Adam that I talked about. In terms of interacting with multiple agents and developing behavior behind that, that is starting to happen here a little bit. Because we build, like right now, we have multiple agents sitting at the county headquarters, and those agents can interact with each other. We really limit their emerging behavior because, again, we want very controlled learning. We don't want them to learn on their own.
Yeah, and of course, they often talk about the limitation of the learning the system, and that we can never see everything.
Well, it's Heisenberg uncertainty principle. You know, the thing is, and again, when we talk about the one graph about whether you're more interested in emulating how a human brain actually thinks or the result of the thinking, most of the major strides from a commercial standpoint in terms of being a product is the latter, is you're more worried about the results. I'm more worried about that I get the plane up in the air versus whether it flaps its wings, okay? But in terms of pure research, there's a lot of people still studying how to make stuff that flaps its wings. So they're still trying to emulate how the actual human works, and that's a valid, I mean, we learn from that. That's a valid approach. But again, what we do is we tend to focus more on making rational decisions, not emulating how the human got there. So.
Well, great.
Like, I'll stick around. I know we're probably running late, but if anybody's got some more questions, I'll stick around for a bit.
Appreciate it. Very nice, thoughtful presentation.
Thank you.